Right, so we have a few minutes, or well, about 30 minutes to go ahead, and you guys can fly away if you have questions, whether about concerns or questions about their PowerPoints or other questions about the oil spill that you'd like to express. Now's your time. So if anybody would like to start, go ahead. Start with Tim's friend. And if you, I'm sorry, panelists, if you can repeat the question so the people on the phone can know what's being asked.
I was curious, Christoph, if you can successfully fingerprint the oil or the residue or the sand patties that you're finding on the beach today, can you trace them to sources like deepwater horizon?
So the question was whether we can still trace like the sand patties we collect now to deepwater horizon. And I'm fairly confident we can. So we made a study and just looking at all these biomarker ratios and had quite a lot of different source oils to compare with. And so first of all, I want to say most of the oil that, or almost 95% of the oil we collect on the shores are deepwater horizon signals. So we find some that have like really a very, very different signal. And second, I want to say many of these biomarker compounds are stable. There's just a few that are not stable anymore. So the point I wanted to make is if we follow the standardized protocol that included all this biomarker thing, then often it would kind of like show up as a no match. But if we exclude them, I still think we get like a match there. I think the caveat I want to say is we didn't fingerprint all the reservoirs that are out there in the Gulf of Mexico. So there's still a chance that there's a reservoir that's pretty similar to deepwater horizon. So for example, the BP surrogate oil is not the Macondo reservoir. And it has a very similar biomarker ratios there. I think this was the point. You wanted to find like an oil that's as similar as possible. If you look closely, you still can differentiate them, but it's getting pretty hard. So the point I want to make, if you have a reservoir that's very close there, and the chances are that the biomarkers also look pretty similar. But from the non-matches we had, they looked like very different than Macondo well oil. I'm not sure.
I forgot to mention the people who are on the phone. If you guys have questions, feel free to put them in the chat box, and we will try to get to those as well. So,
I'm just curious about some of the mechanisms for the calcitrate compounds and their formation. What are some of the mechanisms that cause those formation?
Structure.
Yes.
Microstructure of compounds.
So the question was, what are the mechanisms for this formation of these oxygenated hydrocarbons? Or the mechanism also for the degradation of this biomarker compound. So first, the biomarker, the mechanisms there, we found, so the two mechanisms to destroy compounds is biodegradation or photooxidation. So this is kind of like the two possible ones. We found evidence that some compounds, like the triaromatic sterines, which are biomarkers, which have this aromatic system, they are mostly degraded during photooxidation. This is kind of like what our research currently suggests. This is like things come to the surface, the sun is there, this aromatic system degrades. Then on the other hand, for the hopanes, which have kind of like a long alkyl chain that's pretty yummy for bacteria to eat, we found some indication that it's biology that creates them. For the formation of the oxygenated hydrocarbons, I think the verdict isn't out yet. It's probably a combination of both. We see pretty early, like within these first 100 days, we see formation of these oxygenated hydrocarbons, which my gut feeling is this is mostly photooxidation going on, because the biology takes a while to kick in for this kind of compounds. And then later on in this sand patties that are now submerged under the sea with no light there, we still see increased activity, increased degradation, and we have some indication that biology plays a role there. I think once we get better at molecularly characterize these compounds, I think we can then more certain say what it is. But at this moment, I think it's just we can generally say it's both of these that probably play a role at different times.
I'd like to pitch in a little bit. So this is Charlie talking. Chris is right on, but the part I want to do is back up a little bit. And a lot of the work that was done through investigating or working towards selecting a lot of these compounds that we sometimes call recalcitrant because they degrade very slowly or disappear and change very slowly in the composition of the oil, go back even prior to the Exxon Valdez oil spill when those technologies were developed for fingerprinting and tracking oil. And you have long-term studies that were done, like during the Exxon Valdez, that further refined and validated the approaches using. Now, that said, we're learning all the time, and the work that Chris have been doing and others have been further refining our understanding of that. But there's a lot of confidence from the people that do oil chemistry, and that was my area when I was at LSU, that we're confident with the approaches and the comments made. And even when we look at changes in the profiles, we have certain pathways we think things should take. For example, some of the less recalcitrant compounds should disappear or do more recalcitrant. If those ratios change, we go, oh, something's not right here. There's a lot that goes into this, and so you can do it subjectively, which is how we did it in the old days, or the refinements that started even back in the Exxon Valdez days, where we use a lot of statistics and principal component analysis and different ratios to tease that out more rapidly. But I think there's a lot of confidence that goes back over a quarter of a century using these approaches. They just get better every year as technology and our understanding gets a little bit better.
This is Reddy. I'd like to add to the fact that, ironically, a lot of these advances in biomarkers came from the oil industry. And so in reality, we're ripping off the technology and the approaches from the oil industry. I think the more positive aspect is now the oil industry is looking at some of the technology that we're developing on the oil spill end. And so there is some mutual beneficial aspect, and in fact, often when the oil companies have a little bit more money, they also can help push this forward. So, you know, as much as the environmental academic and the environmental forensic folks should certainly have helped refine it, at the end of the day, I think a lot of the credit in terms of forensics, in this case, the oil industry had some different interests, but they were similar, get a lot of this credit. But now they're riffing off us. So, it's you know, I think that's a good thing.
Yeah. Questions? Well, in the law, I have a comment, I guess, as much a question. But I thought Chris made a very good point. Chris Reddy made a really good point, and communication is so important on how you manage any type of disaster, whether it's a hurricane or an oil spill or a terrorist event. Communication is critical, and having fair communication that, you know, communication is a two-way street. Chris and I will sit together and we'll talk, and other people go, what the heck are you talking about? You have to put it into terms that people recognize and understand what you're talking about. And I think that's probably the biggest lesson, you know, many that I know we're looking at is how do we better communicate the situation, the challenges, the threats, and the strategies that are being used to reduce those threats in a way that people can comprehend, and so we don't go off on tangents, and that people have a very realistic understanding and can weigh the information themselves because it's presented in that manner that they can draw their own conclusions from. And I think that was the real challenge. The whole word with plume took me by shock early on because as you know, from a science perspective, I know plumes are all kinds of things, and it's not shocking when we use the terminology of plume in the context we were using it, but it was surprising that other people saw that same word in a very different light.
Oh, it's climate change.
Yeah, and so those are things you have to, you know, be really aware of, because I totally agree with Chris too in that the things I dealt with day to day outside just helping, you know, manage the response was, you know, the concerns from the public. And even my own family, they'd call me up, Charlie, what's the deal here? And that was a real challenge, and I think it's a very difficult challenge, but that created a lot of concern on people, and some of it real, and some of it not real, but it did add to the real impact of the spill. So I think your assessment was really Well done there.
This is Chris Reddy. I just put up this slide that I use sometimes, which underscores the machinery that what happens in the different cogs when you have what I call an intersection of interests. You know, each one of these cog members are all well-intended, but they all have different goals for success. They have different timelines for success. I need 7 years to get tenure. A media blogger needs 7 minutes to get something up. And Charlie might need 7 hours to make a decision about something. And then superimposed on not only the goals for success is also is certainty. You know, a federal on-scene coordinator would be happy with 70% certainty. If I publish a paper with 70% certainty, I'm going to have a kick me sign on me for the rest of my career. And the media sometimes could have 7% certainty and get away with it. And these are the things that we have to remember. And this goes back to having a cup of coffee with all these other stakeholders. You will not understand the cultures and appreciate this machinery until you visit. It's like visiting another country. I mean, as much as it's laughable, but academia is a completely different country than the bureaucracy that Charlie Henry has to deal with. And until you walk a mile with these folks' shoes, you will not be as effective, and we will not be as capable to respond to another spill. But even more importantly, this cog cannot be turned over like a snowblower in Mobile like a couple years ago. It has to be oiled. We have to be in the planning stage, and we have to be challenged. And so it's really a snowblower like where Christoph lives up in Maine, where it needs to be run a lot. And it has to be appreciated that you can't just think it's going to turn on at a spill. We need to build and understand our other stakeholders so that we understand their cultures and understand their goals for success. And ultimately, that will lead to making a bad thing from getting worse.
I have a few questions that were asked when people registered for this seminar. We gave them the option of asking questions that they still had about the Deepwater Horizon oil spill. So I have a few here. One question is there still a slow leak? Does anybody know the answer to that?
I would say absolutely not, and I think that's a farce, and I think all the data that BP has put forth, and even some analytical data that I have collected a year ago when we were within 1 meter of the shut-in of the well, does not support that. And unfortunately, I think that's a misnomer, and shame on whoever is saying that. And I think that's even in the academic literature, which mystifies me. And I'm an academic snob, I'm not going to lie. But I think that the other thing that I think we have to keep in place is that I think there's grade inflation in academia right now when we publish papers. I think a C paper on the Deepwater Horizon gets a B for a lot of these journals. And so we have to, every paper that gets published is not always 100% right. And there is a paper out there that says there's still, the release is still going on, and there's just no data to support that.
There's another one that talks about dispersants, which you touched on.
Sure.
But it just asks, where does the oil go after the application of dispersant agent?
Monica, can you repeat the question?
Yeah, I'll repeat the question. So the question was, where does the oil go after the application of dispersants? And it's complicated. I mean, the simple schematic that you often see is that the interaction with the surfactants in the oil breaks the surface tension of the oil, makes tiny droplets, the wave energy batters down, gets caught up into the upper water column circulation, and that's where it goes. But it's more complicated because it can actually move deeper than that, depending on the circulation conditions of the ocean at the time. There's the discussions on how does it interact with organic material that's in the water column. In theory, dispersed oil droplets would have less of affinity, chemically dispersed oil droplets, than naturally dispersed because of the surfactant. But there's some stuff in the research that says it's not black and white. It's not clear cut. And that's a general trend. So the oil that's in the water column from the surface, effective dispersant, and it's a long answer, does initially go into the water column. Where it goes after that, because it doesn't degrade immediately, degradation takes time. It may degrade in that upper 30 feet or so of the water column by just being moved around by the wave energy in the mixing zone at upper 30 feet, or it may escape that and go into deeper water, and it may eventually degrade, or it may hatch to something, or it may be ingested actually by by planktonic animals in the marine environment. They may see it as something to eat, and it may actually go in their body like copepods, and even from copepods it may not be totally degraded or digested. It may become part of a fecal pellet that then goes to the sea surface. So if you start to draw out the lines of where oil could go after it's dispersed, it becomes a very big spider web of where it could go. Most of it stays in the water column, and most of it's degraded in the water column, is the general theory and philosophy we work from, but it don't all do that. There's other routes that it does take.
I'm going to expand on biodegradation. And maybe people have heard me say this before, but I can't miss it because it's a pretty good metaphor. Microbes are like teenagers given a chore over the weekend, and they've been told to clean the garage. Can they do it? Yes. Will they do it? Maybe. Will they do it as well as you expect? Unlikely. What will they do? They will do the easiest job first. And so ultimately, don't always rely on microbes. And then moreover, I would underscore that much of the microbe put a cape on it saying it saved the world in the first time scales was really those petroleum fluid natural gases, and that the oil component takes a lot longer to kick in and microbially degrade. And so there was microbial degradation that occurred during the spill in the early time periods, but the excellent science by Mandy Jory and her colleagues and Dave Valentine and John Kessler and others underscored that it was really these gases, the most abundant, some of the most abundant compounds are biodegrading. And then I can't resist the opportunity to say, I don't believe that the Gulf of Mexico was pre-primed for oil. I believe that any water body with any self-respecting microbe who sees oil is going to eat it. Yeah. I have done science fair projects where I tell a kid to take a drop of water out of a puddle in front of their house, and if you add some more seawater and you dose it with diesel fuel in a glass jar, it gets eaten. And so, as much as it might be a little pre-primed, it is not the fact that the spill occurred that made such a huge player. Microbes are opportunistic species. If they seed food in an otherwise barren world, they're going to eat it, especially if it's the filet mignon, when otherwise all they have is celery and peanut butter at the buffet.
That includes the Antarctic and the ice, where they take samples from the ice and isolate oil-degrading bacteria.
Yeah.
So it's ubiquitous worldwide.
Yeah.
Yeah.
Bill Driscoll, he's not here, but he texted a chatted comment. He said, note that NERDA Forensics reported the plume out to 412 kilometers to the southwest based on 1,000-meter depth forensic site. Dissolved oxygen tag and trace of glycol ethers with essentially no relevant TDs.
I don't know.
I would agree. The thing you have to remember was that that the plume was tracked to the southwest, but it was what we would call isopictically spreading. So it was still at 1,100 meters, but it was getting wider and wider and stretched. So yes, it was tracked. Yes, there was a little bit of a sag. John Kessler and his graduate student have an excellent paper in ES&T that says so. Dilution is, our friend in this case. So yes, could we track the plume for many, many months? Yes. Was there a lot more microbes eating a lot of those gases? Yes. But it was getting diluted because it was getting spread wider as opposed to upward or downward. Based on their data and many others as part of the NERDA, which is, of course, we always have to avoid acronyms when we talk about oil spills or anything else, the Natural Resources Damage Assessment, which is essentially the insurance adjusters after a spill, where the response folks are the firefighters.
And on that note, there was actually a question that asked about the concentration of the plume and how fast did it basically, how slow or quickly were these concentrations changing within the plume?
I think that down the time scales that I was lucky enough to study, they were not, the compounds that were within the oil were not biodegrading, they were getting diluted in most cases.
Yeah.
But they were at concentrations that were appreciable. I mean, 5 micrograms per liter means nothing, but it's appreciable per liter for benzene and toluene, what they call BTEX, which are some of the more abundant compounds in gasoline.
Sure.
Hey, were you able to delineate the microdroplet sort of separation from the dissolved phase at any distance into the plume?
We saw a couple samples. This is Chris Reddy, and Dave Hollander just asked a very good question about whether or not we saw any microdroplets and when they may have fallen out of the plume. The data that we have that I think is just getting published and it's online in Environmental Science and Technology shows that there were some microdroplets in the plume and that they certainly fell out with time. So it certainly supports a lot of other data, but we're still waiting on it. And obviously something happened to create the shadow event that whether it's the work that you're doing or collectively with other aspects, but between what Jeff Shanton's paper and Dave Valentine's paper. But I think that's certainly what you're studying, which you're going to talk about today, is going to help refine those aspects about what was the transport mechanism from either the subsurface or the surface to the bottom of the seafloor. I think what's most interesting about this aspect of these microdroplets and dropping on the seafloor is the shadow that we see in the bottom of the seafloor is not as big as what we got oil all the way up to Barataria Bay. That's a pretty long ride. And we also can see oil out in Pensacola, Florida. And so in many respects, the ride that was able to go on the surface was much longer than what we can see in the subsurface. And I think that's interesting to note that when we think about the transport of oil, that depending on what types of oil, what types of characteristic activities we're going with winds, tides, and currents, that what occurred in the subsurface and what occurred in the surface is much different. And I think that's what makes, the chemistry of oil spills is not a beaker in the laboratory measuring pH, but a much more complicated, Mother Nature has throwing a wrench at us and making everything complicated for us. And I think certainly I think from a chemical oceanographer's perspective, the work that Dave Holland is working on is probably one of the most interesting aspects, and I look forward to talking about hearing it this afternoon.
And then, because we didn't necessarily have a speaker who spoke mostly about the surface oil, there was a question of, I don't know if y'all can answer, but how far did the oil travel, and basically where are the largest deposits that have been spilled oil today?
Well, I think I just talked about it, but I think certainly the fact that I think that somewhere to the Florida Panhandle, you can still see oil, and certainly, at Port Fourchon and maybe a little bit west, you can see some, but I think that it's really spread from Florida to Louisiana. It certainly didn't make it to Liverpool.
Well, and to add to that, to kind of follow what Chris said along that question, is that if you look at where can you still find it, and there are those shoreline areas where oil was deposited that was very different in nature than the oil that was part of the subsurface plume, which Chris clarified and provided some contrast to. But the oil that traveled that far underwent different types of degradation, or what we call weathering, because it's not totally degrading the oil, but changes the composition of the oil. And one of the elements of that weathering is what's called a formation of emulsions. And that's why you see oil of different colors, because of the mixture of water into that oil and changing the nature of that oil. That type of oil tends to be fairly persistent in the environment. It's the oil that once it does strand heavily into a beach and it gets moved around, it's very viscous, it's tarry, it picks up sediments and the residues you see on some of the sandy beaches. In marshes, it just adheres to the grasses and creates a kind of a mat that may be buried over. Those can be long-term residues in the coastal environment. And that trade-off that we're looking at, trying to deal with the oil offshore to dealing with the longer-term issues on the shoreline, most oil spills where you want to prevent that long-term shoreline oiling because you do have residues that do remain. As a result of some of the work that's been done from the deep water, people have gone back to the Ictoc spill that was in the late 70s and still find residues that they can link back. Now, it ain't a lot of oil, and you got to kind of know where to look, but if you look hard enough, you could probably still find some in the environment. And that's the same with some of the subsurface oil Once it gets buried in these areas that degradation is very slow, it'll be there a long time. Is it a problem or not? Is it mixed with other things? That's a different discussion. But there is still oil in the environment from that spill. It's a very small fraction, probably, from what it was 5 years ago.
And I think about it as making lemonade out of lemons. Yeah. That we have these, surprisingly very few signals that are easy to get at without a research vessel, and they provide an invaluable opportunity to see how nature responds to this uninvited guest. And so while it's unfortunate that we can still see some sand patties on these beaches, but it's less and less generally, and that there's some salt marshes in Barataria Bay, you know, I think that it's a good thing that we don't have any huge amounts of oil, but as a scientist, the capacity to keep filling in this book chapter about what the fate of this oil is invaluable for us. So at the end of it, we have this tremendous understanding about the fate of oil. And so let's think about sometimes making lemons out of lemonade. I mean, the other way around, sorry about that, because, nature is giving us an opportunity to see how it responds on a time scale that generally we don't.
Right, and just add to that, there's very few places oil from the Deepwater Horizon oil spill stranded and impacted that we haven't worked spills in my career of almost 30 years in a lot of those same areas, and we've followed and tracked it. Not nearly with the degree of science we did with this, which added to our understanding and knowledge, but we've seen the response of the environment and the changes, and we do know that if oil can be degraded, it will be degraded. As Chris said, it's a kind of a competitive world out there, and if there's a carbon source available to be attacked, there's a whole community of degraders out there that are working hard to attack that resource. Sometimes it gets caught in places you can't attack it, and those are the thicker mats or down in crab burrows and things like that. They tend to be more persistent until that oil is made available to them. But we do have responded to spills in a lot of these same areas and watched the transition and monitored the transition over time, and sometimes it takes a while. But we do know that it's less every year is a good way to put it.
Yeah. Also a comment about like this older oil spills. I think a lot of things we learn now from Deepwater Horizon also informs us and allows us to actually go back to like Exxon Valdez. We after Deepwater Horizon, we then analyzed some samples that were 25 years old from Exxon Valdez, and then we saw like, oh yeah, we actually also see these oxygenated compounds here. We just didn't really look at it this way like 25 years ago. So I think it's really this old legacy spills are kind of like a way for us to go back in time and like see like, okay, now 25 years of weathering, how does it look, and then compare this to Deepwater Horizon. So that's,
Going back to your presentation and talking about one of your steps as your disaster control prevention, and then talking about all this communication. I work in the government, so I understand the issues with communication. Have there been any efforts made to actually go back to the oil spill companies and talking about prevention methods and improving them?
You have people in the room that can probably address that. But no, that has been a huge effort from two perspectives. One, efforts on the part of industry to improve their own self-regulation and self-processes. And second, the restructuring of the agencies that were primarily involved in the oversight, which was originally Minerals Management Services, now Bowman Bessie, and changing how they work in those interactions on developing new methods. So I think great progress has been made, but if you have human, I'm a big believer in Murphy's Law, and that no matter how well you design a system or how many checks you put into it to make sure it's not going to fail, if it's humans involved, you will have failures. And I think if you look at the history of time and how not to say the regulations necessarily change it, but the consequences of those regulations, the cost on the industry to respond and deal with different type of pollution events, you see a steady trend downward on such accidents if you go back 30 years, before the Deepwater Horizon, before the Exxon Valdez, and then OPA 90 and changes in rules and management and how things are done. And then all through time, now while there was no major regulation changes that came out with deep water, there was a restructuring to respond to the challenges observed. So I think evidence shows that the trend, even since deep water, has shown a continued downward curve, which was already started prior to that. But if humans are involved, there will be accidents.
I think we have to remember that oil spills are bad for business. So no oil company CEO wakes up in the morning and says, let's have a spill. And so I certainly think that they're trying better and better, and I say bravo to them. You know, the follow-up on what Charlie has said, that, you know, in 1989 we had the Exxon Valdez spill, which spilled 13 million gallons of oil. After that, the next largest oil spill was 1 million gallons in 1991. We had a spectacular track record due in part to great efforts of learning about what happened after the Exxon Valdez. So, you know, we use the term unprecedented for Deepwater Horizon, and I think that you can't underscore that. But, you know, due to great efforts by the government and by industry, we had a great track record. And, you know, it was Murphy's Law. But again, we hadn't had a spill greater than 1 million gallons since the early 90s. I mean, it was a spectacular track record. And then you say bravo to these folks who are involved. The bigger issue is a paper that came out in 2012 that underscores that maybe pipelines might be the biggest sources of oil spills in the future, but what is shown is that the volume is smaller. I think one thing that we have to remember when we think about oil spills and we think about an industry is that I just kept talking about volume. 13 million gallons, 1 million gallons, 170 million gallons. At the end of the day, it's often that it's like buying a house. It's location, location, location. And so the challenges that we face are not only in terms of stopping an oil spill, but also underscoring where a spill may occur and the potential impacts, because some places are much more susceptible to damages than others. And so in the planning stages, we also have to recognize the location as much as the potential release, the type of oil, and the potential of how many assets we can get in theater at a time so that we can reduce damages.
Right. And no matter how small the spill is, if it's in your backyard, it's a problem.
Yeah, I mean, the Costco Busan occurred in 2007. It was 58,000 gallons in San Francisco Bay, and it was dismissed as a relative non-starter. But a lot of excellent work that's been done by NOAA scientists has shown that the herring population was whacked pretty hard. And so there's an example of 58,000 gallons of oil in 2007 that really packed a punch to the ecosystem. So often sometimes you might want to say damages to volume ratio in terms of gauging the impacts as opposed to just volume.
Okay, well, that's great. Do you have one last question? Yes, go ahead.
I'd like to go back to what I think I heard you say about the 90% of the baddies on the beach. Does that mean 10% is coming from natural seeps and existing recovery?
So I think this number is kind of like, we found at one location during one sampling campaign, we find a lot of kind of like very different oil. So this wasn't like oil-soaked sand patties. This was more kind of like asphalt pieces. So just physically they looked very different. And this is kind of like this 5–10%, just like from our data set. But now if we just talk about oil-soaked sand, kind of like this patty type that looks pretty delicious, I don't really remember having analyzed any one of this that we picked that was not McConnell oil.
I would argue that any sample that has this orange tint or reddish tint of sand that looks anywhere from the size of a dime to even larger is, I would say, 99% from Deepwater Horizon. But you have to remember that, in some respects, we're the drunken guy looking for his keys underneath the light post. We are being self-selective. So, these are the challenges. But certainly we have collected samples that are non-Deepwater Horizon. But I can tell you, when we're out in the fields with limited time and at the time it takes to label a sample, if you see something that clearly looks like oil tar that could be from a road that broke down, we don't bother. So that concept of percentage is can be deceptive, because that we have a pretty good idea of the samples that we want to study in Deepwater Horizon, so we continue this long-term study. And so we discount a lot of samples because we know they're definitely not.
And if you move further west in Louisiana and in Texas, there are more sources that create some of the background oil, which you see less of those potential sources on the eastern side of the Mississippi River compared to the west. And so part of that is just the net transport because of the loop current on the west side, and also the concentration of wells and the concentration of ocean-going tankers on the western.
You know, the Texas City oil spill, which happened in March of 2014, we've collected a lot of samples. On one good-sized boulder, we scraped oil off one boulder. We found 3 different oils. Obviously, Galveston Bay is an active place for oil releases, but it just underscores that within probably 30 inches, we found 3 different oils. So yeah, it can be a complicated background, and again, this provides extra challenges for the Gulf of Mexico. But I think in the sand patty regime, if you can see it, I don't even think I need my $100,000 gas chromatograph to confirm it's deepwater horizon.
Okay, well on that note, we're going to go ahead and break for lunch. Those people who are online, we're going to put the phone on mute so you haven't been disconnected, but we will be returning at 1 p.m. Central Standard to start our afternoon sessions.